All right. So the first question reads as follows. A 45 kg woman stands on a spring scale inside an elevator. The scale reads the force with which it pushes upwards on the woman. What does the scale read when the elevator is accelerating upwards at 3.65 meters per second? Then B, that's supposed to be B somewhere there. B, 3.65 meters per second downwards. The first thing to be aware of here is that we are dealing with forces, and we are told there is acceleration which is happening. Acceleration only happens if there is a resultant force. Okay, so in this case, this woman has got a mass of 45 kg. That means that this woman has got weight. The weight of this woman is 45 kgs times 9.8 meters per second squared. That's the size of the weight. The weight of this woman points downwards. Is that clear? Always. The weight of anything points down. Okay. The other thing to notice is, as much as this woman has got weight, she is standing on a scale. Okay. And we are told that the scale exerts a force with which it pushes upwards on the woman. So the woman is standing on the scale. This woman is exerting a force on the scale. The force she's exerting is her weight. Okay? Then the scale does not seem happy about this arrangement. So the scale is also pushing on the woman. Is this clear? Hello?
Yes, sir.
Yes. So the scale is pushing on the woman. So there is a force which a woman is exerting on the scale. There is a force which the scale is exerting on the woman. There are two forces. The force the woman is exerting on the scale, that is her weight. The force which the scale is exerting on the woman, that is the reaction of the scale on the woman. It only exists because the woman is exerting a force on it. Okay? Or basically you can say the normal force. Like that. This force is pointing upwards. The weight is pointing down. So we've got two forces. There's a force which is pointing down, which is the weight of the woman. There's a force which is pointing up, which is the force the scale is exerting on the woman. Okay. After having established these facts, the next thing we need to decide is the directions. These forces are acting in the y direction. Which direction is going to be positive, which direction is going to be negative. So we need to choose. So we are told there are two directions here. There is upward and there's downward. Okay? Up and down. So we need to choose which direction is going to be positive. We need to choose which direction is going to be negative. So in our case, we are going to choose So in our case, we are going to... Hello, can you mute your microphones before we throw you out? So in our case, we are going to choose the up direction to be positive and we're going to choose the down direction to be negative. Then after that, we're going to use Newton's second law of motion. Okay, so let's get started with this problem. So first of all, so the woman with mass 45 kg, 45 kg exerts her weight on the scale, which always points downwards. That's the first thing. The weight of the woman. Okay. So the weight of the woman, this woman has got a mass of 45 kgs. Then this weight is pointing downwards. That's the first thing we notice. That's the first thing we work out also. So the weight of the woman is found to be weights, which is the mass of the woman, mg, which is equals to 45 kg 45 kg multiplied by 9.8 meters per second. So how much weight do we get? 45 times 9.8 meters per second. What's the weight?
It's 441.
So the weight of the woman, we get that as 441. The units? What are the units? What are the units of weight? What units does the weight have? Hello? What are the units of weight? We are asking for the units of weight. We are trying to work out the weight of this woman. We have multiplied her mass, which is 45 kgs, times the acceleration due to gravity, which is 9.8 meters per second. The size we have been given is 441. What are the units? What are the units of weight?
Newton.
Okay, newtons.
Newton.
So this woman weighs 441 newtons. This is how much
So we will
weight.
not give the Newton. Why?
This is how much weight she is exerting on the scale. Okay. So the woman exerts a weight of 441 newtons on the scale. The scale is unhappy about this, is unhappy, and reacts by exerting an upward force F of a known size. So this is what's happening. The woman exerts a force Fw So the woman exerts a force of 441 newtons on the scale. The scale is unhappy about this and it reacts. So it pushes back by exerting a force F, which is unknown, of a known size. That's good. We know something, however. We know that the woman as a result accelerates upwards with a y acceleration in the y direction being equals to, what are we, 3.65 meters per second squared. So that's what's happening. She exerts this force on the scale. The scale is unhappy. It pushes upwards. As a result of this pushing upwards by the scale, she accelerates upwards like that. Okay. Now the next thing is, since we are dealing with vectors, direction is very important. Since we are dealing with vectors, direction becomes very, very important. We proceed to choose the upward direction to be positive, and the downward direction to be negative. So that bit has to be done. So we choose directions. Which direction is going to be positive? Which one is going to be negative? The next bit is we identify which forces are pointing upwards, hence they're going to be positive. Which forces are pointing downwards, hence to be negative. The weight of the woman points downwards, hence is designated as a negative force. The push of the scale on the woman on the woman points upwards and therefore is designated as a positive force. Next, the woman is seen to accelerate upwards, therefore the acceleration she experiences is positive. Okay, so this is what we could gather as a result of deciding the directions. When you decide directions, say fine, up is going to be positive, down is going to be negative, then you identify which forces fall under this block. The forces pointing up in this case is the push of the spring on the woman, that points up. The forces pointing down is the weight of the woman, that's pointing down. Then of course she's accelerating upwards, therefore her acceleration is positive, like that. Oh, what have I done? I typed okay. So I've seen already. So this bit is supposed to come down here. I can't. Yeah, so here then we choose directions, positive and negative, then as a result of that, the next thing is we apply Newton's second law of motion, which talks about the net force or resultant force and how it relates to the acceleration of the body. So what does Newton's second law of motion say? So I'm going to write it. Now in the y direction, MA in the y direction. We're applying Newton's second law of motion in the y direction. That's the only direction which is there anyway. This is Newton's second law of motion. This summation thing, that is the resultant force, where some PHY is the resultant force in the y direction, then M is the mass of the woman, then y is the acceleration of the woman in the y direction. So that's what these things are. This guy here, as I've explained here, this is a resultant force. Oh, the spelling is a bit fishy, not correct. Resultant. Okay, resultant force is the resultant force in the y direction. The m is the mass of the woman, then the ay is the acceleration of the woman in the y direction. Are we clear so far about Newton's second law of motion? So the only thing we need...
Yes, sir.
Sorry?
Yes, yes.
Yes, so the only thing we need to do is we need to find this, the resultant force in the y direction. Because once we find the resultant force in the y direction, everything else is known. We know the mass of the woman. She has got a mass of 45 kgs. We also know her acceleration. We've been given the acceleration. Her acceleration is this, 3.65 meters per second upwards. Since it's upwards, we have said anything pointing upwards is positive. So acceleration is positive, upwards. So that bit we know. The only thing we need to know is the resultant force. Is that clear? Are we clear? So we proceed to find the resultant force. The resultant force that's as follows. So we know the forces acting on the woman. There are two of them, the weight and the reaction of the thing. So these speeds shouldn't be very difficult, people. That will be equals to F. The F is the force of the spring on the woman. It's pointing up, that's why it's positive, plus the weight of the woman, which is negative because it's pointing down. That's what you have. That we get that. That will be equals to F minus F W. F minus FW. This. So we have found the resultant force. The resultant force is equal to this. So the only thing we need to do is equate this resultant force, which is this thing, to this. Okay. We get next. We get which is equal to MAY. This. So we do this. So we know these bits. This bit we know. It's this bit. It's F minus FW. The F is the force of the spring on the woman. It's pointing up. Then the FW is the weight of the woman on the spring. It's pointing down. So it's negative from the choice of directions we made up here. We decided to say up is going to be positive, down is going to be negative. So it's coming from there, like that. Then we already know a bit of things. We know how much this is. It's that. That is known. We also know the mass. The mass of the woman is known. The acceleration is known. So we can substitute these things. Okay. So substituting. We got there, the mass, the woman's mass is 45 kgs. the acceleration. Oh, sorry. And the acceleration we are given as 3.65. 3.65 meters per second squared. So this is what we get. We get F minus these bits, then that bit. We take this bit on the other side. We end up having becomes positive or plus. How much is this end here? 45 times, how much is this? 3.65. (45 times 3.65).
164.25.
164.25. So we end up having 164.25. And what are the units? What are the units of multiplying? What's the result of multiplying kgs times meters per second squared? What are the units of this? Kgs times meters per second squared. What do you get? What do you get as units?
Newtons.
You get newtons. So this is what we end up with. We end up with F is equals to 441 newtons plus 164.25. How much does it give us? Just a minute. So how much do you get for this? 441 plus 164.25.
605.25.
605.25,
Yes.
like this. Okay, so that's what we get. So the spring is going to have a reading of this 6. So the spring will have a reading of 605.25 newtons. Are we clear about what you have done and how we proceeded to go about this? You have to make decisions. You have to identify the forces, if there are any, because you're dealing with Newton's second law of motion. So there's definitely a need to identify forces. You have to identify which directions these forces are pointing in. Then you have to choose directions. Which directions will be positive, which ones are going to be negative. Because when you're dealing with Newton's second law of motion, you need this guy, the resultant force. For you to get the resultant force, you need to add a bunch of forces. It's only the resultant force which is equal to mass times acceleration. And like this. Therefore, you proceed to find out how much the resultant force is supposed to be. Like this. Okay. Any questions?
No, we move.
No questions? Okay, so if there are no questions, next bit is now the elevator is moving down at with an acceleration of 3.65 meters per second. Okay. The forces, the weight and the pushing of the spring, they're still the same. They haven't changed. Okay. The direction of the weight of the woman, and the force, the spring exerts on the woman remain unchanged. They are still the same. Therefore, the resultant force the woman experiences is in the y direction is still given by this. Nothing has changed. The direction of the forces acting on the woman hasn't changed. Therefore, the resultant force, we still get this as a resultant force, F minus FW. That's what we get. Okay. However, something has changed. However, the acceleration has changed direction. In this case, the woman accelerates downwards. Since we chose upward direction was positive and downward direction was negative, the woman experiences a negative acceleration of size of magnitude 3.65 meters per second squared. That's what he experiences. So the only thing which has changed as far as this woman is concerned is basically the direction of acceleration, which is now pointing the negative direction. The resultant force still remains the same. Okay. So next we apply Newton's second law of motion. Is this clear? Is what I've done clear so far? Hello?
Yes, sir.
Okay. So if that's clear, that's fine. So next we have to apply Newton's second law of motion. We have to do these. Okay. So next we apply Newton second law of motion on the woman as follows. So basically we have to do that. Where is that? We have to do these bits. Yeah, yeah. The sum of the forces in the y direction, we have this bit, it remains unchanged. That's what you have here. Then that. Then you've got this bit. So the one it ends, that is this. And that is that. So when you do the substitutions, the only change now is the acceleration. In our case, the acceleration is negative because this bit. So there is this, that's fine. The weight of the woman doesn't change because she's going down, it's still the same. The mass of the woman equals to the mass, so this is F. The weight of the woman remains unchanged. Whether you're going up or down, it's still the same. The mass of the woman, that's 245. Then now you've got this, AY. Now it's negative. There. So that bit, you multiply 45 times that, you get ourselves, what do you get? What did we get previously? How much you get? $45 times minus 3.65. How much do you get when you multiply this?
Negative 164.25.
Negative 164.25. And what are the units? So this is what we get. We get these. So now that we have got that this side, we get this guy, take him to the other side. They're 441. Take it to the other side. So end up with this. F is equals to 441 newtons minus 164.25. So how much do we get? Just a minute. How much do we get? 441 newtons minus 164.25. $276.75. That's what you get. So in this case, so when the woman accelerates downwards, the spring reads 276.75 newtons. Okay, are we clear? Yeah. So basically the whole thing really is testing you. You have to identify forces. We have been taught this woman has got mass, therefore this woman has got weight. You have to have an clear understanding of where the weight is pointing. The weight is pointing down. It always points down. Then you are also taught Yeah, the woman is also experiencing a force because the spring is pushing upwards on her. So you have to understand the fact that the woman has got weight which is pointing down, and the woman is also being pushed up by the spring. So there are two forces acting on the woman, like that. Since there are two forces acting on the woman and you've got two values of acceleration up and down, the next thing you need to do is you have to understand that you're dealing with vectors. So you need to choose direction. This direction is going to affect all the vectors, whether it is force or acceleration. So if you choose up to be positive, then you choose down to be negative, then you stick to that. Then you make sure each of all these forces, everything pointing up is positive, everything pointing down is negative, and you stick to that during the calculations. And the only thing you have to use is this one, Newton's second law of motion. The resultant force Fy is equal to the mass times the acceleration in the y direction. So the business really is to find the resultant force, which of course you can find easily because you just add the forces which are present, and you have already given these forces their signs. Any force pointing up is positive, any force pointing down is negative. So you end up with this as a resultant force. This resultant force does not change whether the thing is going up or down. The only thing which changes whether you're going up or down is the acceleration. If you're pointing up, you're going up, then your acceleration is positive. That's why we ended up using a positive acceleration value here. In this other case here, because it's going down, that's why we ended up using a negative value of acceleration, and we have found different values of the spring readings like this and there. Okay. Are there any questions? We can only do, because now we have reduced our things to only 1 hour, the target is only in this 1 hour to only work out one question properly. So we can't move on to question number 2. Question number 2 will be done tomorrow. But I encourage you to study the images for question number 2. Any questions?
So I have a question. So the video will be saved on YouTube. This same video. Or
Sorry?
I'm saying this same video. Is it going to be saved on YouTube?
Yes, I'm going to upload it to YouTube before I leave this place.
Alright.
Yeah, it will be uploaded to YouTube. Any other question? Okay, if there are no other questions, then we'll stop here. I will upload the PDF to Moodle. I'll also upload the video to YouTube so that you can watch. All right, we come to an end. I'll stop sharing. Have a good night and see you tomorrow.